Let's talk about networking with Python. So the first thing is banner grabbing, which we've actually already been doing a little bit of in some of the other challenges, although I didn't call it that. So if I make grab.py, here I just make a socket object and I connect to one of my servers on port 22, the SSH port, and print whatever data comes back just from the TCP handshake. That's all the connect method does, is syn senac ac. So if I run that, it connects to the server. Now the SSH protocol specifies that you must reply to the handshake with the version of SSH you've got. So it does send some data, and I see it there. So that's fine. Now let's make an error by just changing it to a server that doesn't exist. So I'll copy that. This, by the way, is a good practice. Whenever you have any program that works at all, I keep it and move to another copy, because often I foul things up and I wish I could go back to the one that worked. All right, so if I change this to a server that doesn't exist, like XAD, and run that, then it gives me an error. Now, it gave me a couple of ugly lines up here telling me which line of code had the problem, and then it had sort of an intentional error message down here, and this is why you might actually want to do error handling, which we aren't doing much of, but the pros do error handling, and there's some projects where that would help. So that would be, or instead of doing something that might fail, you try to do it with try, and then you indent this stuff, and then you have an except, which is what happens if an exception happens. And here it's socket error. As error, we'll catch that error, and then you can do whatever you want, like print that out. There. Now it shouldn't just crash and give me like an ugly automatically generated error message. It should have my custom error message, which is cleaner. And there, I just see the node namer server. It makes it cleaner. It also means, by the way, if you're in a loop, like scanning, looking for a port that might not be open, your program won't crash the first time a port is not open. It will just have an exception which you can handle and then go on to the next port. So now we can try the timeout. If I modify this one to go to a server that does exist and a port that is open, but it's an HTTP port, like 80, then I'm going to have a different problem. If I run this one, it makes me wait forever. And this happened to a student earlier who had sent a message to a server and then was waiting for the reply, but no reply was coming. It's not broken and your code is working, but it's pausing because port 80 is for web browsers and HTTP does not have a banner. It does not send any message. You're not supposed to just send a handshake and wait for a reply. You're supposed to send a handshake followed by a valid HTTP request. So my Python code is waiting for the server to send a banner, and the server is waiting for my code to send a request, and it will wait for like 2 minutes before moving on. So if you don't want to wait forever, you shorten the timeout with this command. You put in s.setTimeout, another method of a socket object. And you can set the timeout to something small like 1 or 2 seconds. And now it will not wait forever. Oh, I do have to spell it right though. It's set timeout with 2 T's there. All right. Now it only takes a second, and then it gives you an error timed out. So that's kind of cool. And as you see, we're slowly building Nmap here. And the last thing would be to take user input. So let's, I think I'll just keep modifying the same file. So here, I'm going to get the port number. So I'll say p port, and you can read input. And then you put the prompt, port number, : And when it replies to that, it gives you a string. So I'm going to run it through int to turn it into an integer. And now I have defined the port number that's variable, and I can put the port number here instead of 80. So that should work if I haven't fouled it up. So if I give it 22, I get a banner. And if I give it 80, then it times out. So that's cool. By the way, this is still a kind of sloppy program, because if I give it something that's not a number, like Q, then I just get one of those ugly messages because I didn't use a try to catch that error. In principle, I could have. All right, and so now you got some challenges. There's a service that will send you a flag when you connect on one of these ports ending in an even 1000. And then there's a service on this other server. You have to scan from 21,000 to 21,030. And then there's one that combines all the things you've done so far. When you connect to this one on port 22010, it's going to reply with a port number, and you have to find that port number and connect again right away, within a few seconds before it hangs up. This is a very simple case of what they call port knocking, an old trick to hide a secret backdoor into a server, either for system administration or because you're malware. So you listen for knocks on closed ports. The classical one is you knock on 7,000, 8,000, and 9,000, and then you open 22 for just a second or two. So you can have SSH, but only if you knock to open the door. And the point of this is if you run a scan, like an Nmap scan, looking for ports, you will not find it. All the ports that receive the knocks are closed all the time, and the SSH is closed until the right knock comes in. So this is a way to hide a secret backdoor into a server. Here I only have one knock, but anyway, you knock and it will tell you what the other port is. Anyway.
How fast is that opening? Because I sent right away, and I know it's sending the right integer and it's replying to the right port number, but then it's getting connection refused.
No, it should open right away. It shouldn't take much time at all. So after this, let me share your screen. We'll see if we can figure it out. And the next one is just a minor variation of the same thing. It just hides it in a paragraph. So you have to hunt a bit more through the text to find the port. So those are some port knocking challenges. And I think I'll stop this video and let me see if I can debug your port knocking.